Hey guys, so last week we used the first derivative test to tell us where a function is increasing or decreasing. If the first derivative is positive, the function is increasing. If the first derivative is negative, the function is decreasing. And if you look at that chart that I gave you that I said is very important, you'll notice those relationships are already there. You'll also notice that where the first derivative has zeros or where it crosses the x-axis, the function has critical points, which is the fancy calculus way of saying that the function has minimums or maximums. So what we're going to do today is we're going to continue practicing the first derivative, except we are also going to use it to classify critical points of the function in addition to whether it's increasing or decreasing. So you've got our function 2/3 x cubed minus 4x squared. It's the one on your guided notes, and the graph of the function accompanies that. You can see where the critical points already are. But what we're going to do is we're going to use the first derivative test to prove that. So first we're going to take the first derivative. Oops, there we go. So f prime of x equals 2/3 times 3 is going to be 2x squared minus 8x. And if you factor that, we take out a GCF of 2x to get x minus 4. And we're going to set that equal to 0. And you get x equals 0 and 4. Get all that down, give you a second, and then we're going to erase it. All right, so we've got our zeros. Now we're going to do our number line test. So remember, we make a number line, 0, 4, and let's see if it'll right there. You got f prime of x, and you got f of x. Awesome. All right. So what we're going to do is we're going to pick a number to the, we know that 0 and 4 are where the derivative crossed the x-axis, right? That's where the derivative has zeros. So we're going to pick numbers to the left and right of 0 and 4 and in between to do the first derivative test. So I'll pick -1, 1, and 5. Easy numbers. We're not trying to make this thing too complicated. So if I plug -1 into the derivative right here, I'm going to get, it doesn't matter, we don't need the answer, we just need to know if the answer is negative or positive. So 2 times -1 is negative, -1 minus 4 is negative, a negative times a negative is a positive. This function is going to be increasing from negative infinity all the way to 0. If I put 1 in, I'm going to get 2 times -3, which is a negative. This function is going to be decreasing, and we know it's decreasing all the way to 4, where the derivative gets back to the, or sorry, excuse me, where the function gets back to the x-axis. Sorry, no, where the derivative gets back to the x-axis. It's the 0 of the derivative. And then when I put 5 in, I'm going to get 10 times 1. That's definitely positive. This function is going to be increasing. So that is where we left off on Friday. We used the first derivative test to tell us where a function is increasing or decreasing. And today is almost exactly the same thing, but now we're going to talk about whether the function has minimums or maximums. So if you look at this 0 right here, what's happening there? Well, we know that the first derivative is crossing the x-axis, which means that the function either has a minimum or a maximum. And if you look up here, we know the function is increasing. Here, I'll use a different color. We know the function is increasing, and then it goes from decreasing. If you just connect these two arrows, you're going to get a maximum. So, and then over here, if you look at the arrows, if you just connect those arrows, that function is going to have a minimum. And if you look at your graph, it checks out. You got a maximum at 0 and a minimum at 4. So if I were to justify this answer, I would say, see if I can fit it down here at the bottom, f has a max at x equals 0 because, so let's talk about how we know f has a max. What would you say? Well, you might say, well, the derivative has a 0, therefore the function has to have a maximum there, but that's not quite true, is it? The derivative has a 0. The derivative having a 0 tells us where the function has a critical point. So in order to prove that there's a maximum, we have to say that the derivative goes from positive to negative. So f has a max at x equals 0 because f prime of x goes from positive to negative. Full justification. F has a max. Where it has a max, derivative goes from positive to negative. Let's go ahead and do the other justification here. Going to cut off the bottom of those numbers, sorry. All right. So we can also say that f prime of x goes from negative to positive at x equals 4. Therefore, f has a min. Either way you do it works. Sorry, the I is not working very well, but you get the idea. So, it's the exact same thing as Friday, just with a little add-on. We're classifying minimums and maximums of critical points.